portion. Basic properties of two similar triangles. That I think most of us knows. These are two similar triangles. Let's consider two similar triangles. This is triangle ABC. This is PQR. Two similar triangles. Now, how do I identify similar triangles? There are some properties. One is angle, angle, angle. If all the three angles of a triangle are equal, or any two of the triangles, suppose this angle, this angle, this angle, this angle are equal, then the triangles are similar. This is our angle, angle. Then we have side, side, side. If the sides are proportional, side, side, side. SSS means AB by PQ equals to BC by QR equals to CA by RP. This is our SSS criteria. In case we will have triangle ABC similar to triangle PQR. This is our case. We are going for the possible case. Sides are proportional, SSS criteria. Then we have SAS criteria. One included angle and the two sides are proportional. Suppose this angle are equal and AB by PQ AB by PQ, AC by PR, AC by PR. This is our one criteria. This is side angle side. In two sides and the included angle. Two sides are proportional and the included angle is equal. Then also we are getting similar triangles. Angle, angle. Now, what are the basic properties of similar triangle? Similar triangle may or may not be congruent. Congruency, what is the relation between congruency and similar? Congruent triangles are similar. Congruent triangles are similar, but not vice versa. But not vice versa. Means similar triangles are not congruent, not always congruent. What are the properties of similar triangle? Properties of similar triangle is sides are proportional. Angles are equal. Angles are equal. Sides are proportional, angles are equal. So this is the most basic of similarity of triangle. Let's move ahead with the theorems cleared. A very common theorem whenever we are studying anything like similarity of triangle that we need to remember is angle bisector theorem. Angle bisector theorem is one of the most common theorem. Whenever we are learning similarity, we should go for this. In NCERT also this is there, NCERT class 10. For any triangle, what is the theorem I am seeing? Prove that Prove that for any triangle, the angle bisector of any interior angle. For any triangle, the angle bisector, of any interior angle, any interior angle must cut the opposite side, must cut the opposite side into two segments, such that their ratio is equal, such that their ratio is equal to the two sides of the angle. Angle correspondingly. That means what? I know my handwriting is really ugly. That means that if you are given, suppose, a triangle, this is the angle bisector, and these two segments formed are having ratio, the ratio of the two segments, let it be A and B, is equal to the corresponding sides of the angle, this side. Okay, let it be X, let it be Y. That means A by B equals to X over Y. This is the angle bisector. You have to prove this thing using what we have learned here. Let me prove it. It's really easy. I know most of you have proved it. Nothing is there. Nothing difficult is there. Let it be the triangle ABC. Let it be triangle ABC. This be the angle bisector meeting BC at the point E. Now what I will do, I'll just extend this part. Extend this part. Extend this part. And extend this part also. Such that this part is parallel to this part. Then they will meet at a point. Okay, they are meeting at a point. Let me just read out the diagram. We are having a triangle like this. This is our angle bisector. I have extended this and I am creating a line which is parallel to this one. This and this are parallel. This is the angle bisector of this angle. This is the angle bisector. This angle are equal. Suppose let me give them a name, ABC, and this point be E, the meeting point. Let the meeting point be E. Let the meeting point be E. Now since these are parallel, we can just look at this angle. You can just think it yourself, that this angle this angle is equal. And this angle is also equal, because these lines are parallel, this, isn't it? These are corresponding angle, these are alternate angle. These are corresponding angle, these two are alternate angles. So again, this is the angle bisector. These two angles are equal. So this angle equal. This side also comes equal. This side equal to this side. Now what we are going to prove from this point? We will just simply prove that. Here we just prove it. You just see. This side AB, this triangle ABD, triangle ABD is similar to triangle EBC, isn't it? Now what we are getting? We are getting triangle ABD similar to triangle EBC. So this is very simple. This line is parallel, this angle equal, this angle also, this angle equal, this angle, two angles are equal, angle we are getting. So what we are getting from these points? We are getting that AB by BE equals to AB by BE equals to, this is properties of similar triangle. AB by BE equals to AB by BE equals to BD by DC. This can also be emphasized as BE minus AB over AB, CD minus BD over BD. How this steps comes? If we just subtract, this can be written as BE over AB equals to CD, not CD, CB, it should be CB, CB, this side, CB, this can be written as CB over BD. I hope you are understanding. Now I can subtract -1 from both sides. Subtracting -1 from both sides gives us this. This is CB, this is CB. Now what we are getting from here? We are getting that this will give us AE over AB equals to DC over BD. So now what we can emphasize? AE CD BD, you just see CD BD, I just repeat, CD BD, the ratio of these two segments equals to AE. AE is what? A equals to AC. A equals to AC, we have already proved it. AC over AB, corresponding sides. CD AC BD over AB, BD over AB. Is it clear? I hope it's clear. Let's move forward. Now we have projection theorem of right angle. I'll not help you because this is really basic things. You have to do it yourself. I just give you the hints. I'll just give you the hints. Given triangle ABC, such that angle ACB equals to 90 degrees. Then we have to prove the following. This is called projection theorem of right angle triangle. Projection theorem of right angle triangle. We have the following. CD square equals to AD into DB, AC square equals to AD into AB, BC square equals to BD into DA, where CD is perpendicular to AB. CD is perpendicular to AB. This is really simple. There is nothing difficult here. Most simplest. I am just giving you the diagram so that you can get a better idea. ACB. Okay, here it's right angled. It's a triangle. CD is perpendicular to AB, and you have the following. We just try to prove it. I am moving to some problems. Okay, before moving to problem, another thing that is really interesting, often coming in many examination, is theorem of centroid. Most of us know this theorem, but very less are interested in this proof. Suppose we are having a triangle. Now the question is, what is centroid? What is centroid? The intersection point of the three medians of the triangle. Intersection points of three medians of the triangle. This is the definition of centroid. Now what we know? We know that if this B is median and this B is median, this B is median, this ratio is 2:1. We all know this. Now how do we prove it? I'm just giving you a hint that how can you prove this. Some teacher shows the proof by drawing parallelogram. Okay, this is also correct. I'm not saying that this is not correct. But there are different proofs also. Different proofs available for this. My proof is simple. Let me give them some name. Without name, that didn't look good. A, B, C, D, E, F. Let me draw a parallel line meeting this point at A, B, C, D, E, F. Centroid is generally named as G. Let it be H. A, B, C, D, F, G, H. Okay. So this is the midpoint. This is the midpoint of, let's consider this triangle now. Let's consider which triangle? I'm just saying to consider only this triangle, okay? BCE. In BCE, D is the midpoint, DH is parallel. Therefore, H is the midpoint. This side equal. By midpoint theorem, then what we are having, you just see. And we know that this is the midpoint of this AE. AE equals to EC. We know this. A equals to EC equals to 2 CH. We can write it. AE equals to EC equals to 2 CH. Is it correct or not? A equals to EC equals to 2 CH equals to 2 HE. Now here you use similarity. How will you use similarity? Triangle AGE. This triangle, okay? Triangle AGE is similar to triangle ADC. Similar to triangle ADC. Now the proof is in our hand. Find the value of AG by GD. Quick. Find the value of AG by GD. It's A by H. Am I correct? A by H. Now what's the value of A by H? AE. Here I am having HE. A equals to twice of HE. AE equals to twice of HE. From here, okay? Here to here. AE by EH equals to 2. Equals to 2. AG by GD equals to 2. Is to 1. Hence proved. Some are proving this by drawing parallelogram and like that. Why use such complex method? Such simple and elegant method using just midpoint theorem is available. So why to go for this complex method? No use. Now this was basic of similarity of triangle. After solving this problem you should solve now. This problem you should solve now. Then you should proceed further. Pause the video, solve now. Now this is our first problem. First problem. A straight line passing through the vertex A, this would be large A. A straight line passing through the vertex A of square ABCD intersect side CD at E and line BC at F. Prove that AE square, a straight line passing through the vertex A of a square ABCD intersects side CD at E and line BC at F. Prove that 1 over AE square plus 1 over AF square equals to 1 over AB square. I'm solving it. A straight line passing through vertex ABCD. A straight line passing through vertex A of square ABCD. Passing through this vertex A of ABCD intersect side CD at E CD at E and line BC at F. That means it would definitely intersect BC extended. You have to understand the question. Side CD, line BC. Line means what? It's not ending. Line BC at F. Side CD at E. Prove that 1 over A square plus 1 over. This is a very trivial question also. Common question equals to 1 over AB square. 1 over A square plus 1 over AF square equals to 1 over AB square. Solve it fast. Fast. and I won't give you much time. I just solve it in 1 or 2 lines. I just solve it in 1 or 2 lines. Yes, 1 line question. Then I'm not having enough space, otherwise it will be solved in 1 line only. I'm giving you an idea. Think with the idea of angle EAD. Think with the idea of angle EAD as some alpha. And then interpret the sides in terms of this angle, some relation between them. Okay, I'm solving it. Find the value of cos alpha. Find the value of sin alpha. Then you are done with it. Cos alpha. This is right angle, okay? Cos alpha. AD by AE. Is it correct? I'm always correct. This is DE by AE. So you can write them in terms of AE, yeah? And also another possibility is AB over, let me extend it. This is what? This is AB, this part. This part is equal to AB. AB over F. This is also possible. Why not? This is also possible. Possible value of sin alpha. Now it's done. Now you just find out the value of 1 over A square plus 1 over F square. You are done with it. Nothing to worry about. Find out the value of AB over AE. AB over AE. I guess AD and AB are equal only, isn't it? So we can also write it as AB, because this is a square. AD and AB are equal. So what we are having, 1 over AE is nothing else but AB will have a denominator, cos square alpha plus sin square alpha. What is the value of this? 1. Hence proved. Now you would ask me, sir, you are teaching a similarity. What was the similarity about? That's the interesting part. You can also prove it using similarity also. The similarity and the concept of sine, tan, these things, all these things are what? Are based on similarity of triangle only. We are getting 2 values of sin alpha. What we are doing, we are getting 2 values of sin alpha, isn't it? We were getting 2 values of sin alpha, I guess. So this is possible because of similarity. This was possible because of similarity. That's why I am saying it's a question on similarity of triangle. Let me proceed to the next question. This is our next question. The line segment BE divides triangle ABC into 2 similar triangles in similarity ratio. What do I mean by similarity ratio? Similarity ratio means what? We are having 2 similar triangles of length PQR ABC. Then the sides are proportional such a way that they have a constant of proportionality, isn't it? Their ratio being equal to some K. and here this k is root 3. Okay, this is similarity ratio. Line segment B divides triangle ABC into two similar triangles, their ratio being equal to root 3. What we have to do? Find the angles of triangle ABC. We have to do this. Beautiful question. Should I solve it? Okay, I should solve it. You can try more. Draw the triangle, you'll get it. Let's start solving it. Since, okay, let me draw the triangle first. Otherwise, it will be very difficult. This is one possible diagram. I'm thinking that why I have drawn a right angle triangle, because this is most suitable diagram. I know the angles, that's why I have drawn this diagram. You can draw any diagram. I know the angles, isn't it? I'm having the solution. The line segment B divides triangle ABC into two similar triangles. BE. How is it possible? Is it possible? You just say, is it possible? Why it's not possible? Let this be E. Let me change my diagram for a clear perception. Let's focus on this diagram. This would be easy for us. Since, okay, this is 180 degrees, there is no doubt, I guess. And these angles need to be equal. Why? If this is not equal, suppose this is X, this is Y. Okay, then this angle is some theta. We will not be able to find any kind of similar triangle. They can only be similar if this is perpendicular. This is the only case. Why I am saying this? If they are perpendicular, if this is theta, this is 90 minus theta. Then what will happen? This is 90 minus theta. This angle will be some alpha. This is 90 minus alpha. They are similar triangle. We'd get some relation. Otherwise, we cannot have any kind of relation. Okay, that you have to understand. When we are practicing a lot of question, we are getting this idea that yes, they have to be perpendicular. Otherwise, the triangles cannot be. Otherwise, the triangle cannot be similar. That is the idea. That is the idea. Now, I am saying that these are perpendicular. I have given you the best hint. These are perpendicular. These are perpendicular. This is perpendicular. Only this is the case for our possibility. Now you just think. Now two cases we have. Two cases are possible. Either this angle ABE equals to angle CBE, alpha alpha. Suppose, let me name them 1, 2, 3, 4. Angle 1 equals to angle 2. This is one possible case. And another possible case is what? Another possible case is that angle ABE, angle 1 equals to angle BCE, I guess. Yes. Angle 3. These are the two possible cases. Now we have to work with case studies. The first case should be discarded. Why? Because if we consider the first case, what will happen? These two triangles will be congruent, isn't it? Angle, angle, side. ASA criteria of congruency, these two will be congruent, but we know that they are not congruent. They have a proportionality ratio of 3, root 3, not 1. So first case is discarded. Now we have got the case. We can just finish it. This is our only possible case. In the second case, we are having angle ABC equals to angle 1 plus angle 2. Angle B equals to angle B equals to angle 1 plus angle 2. Now you just think, this is 90 degree. This is what? 90 minus angle 4. Am I correct? So angle B can also be written as angle 3 plus angle 4. You just think, what is the sum of angle 3 and angle 4? If I am wrong. Because angle 1 equals to angle 3. Angle 1 equals to angle 3. Is it okay? Angle 1 equals to angle 3. So angle B can also be written as twice of or anything else. You just think again. What is the value of angle B? From this, what is the value of angle B we are getting? 90 degree. Is it clear or you are having doubts? What we are getting, you just see. Angle B equals to angle 1 plus angle 2. Angle 1 equals to angle 3, angle 2 equals to angle 4. Then angle B equals to angle 3 plus angle 4. Angle 4. If we just add them, what we are getting? Twice of angle B equals to angle 1 plus angle 4. Angle 1 plus angle 4 plus angle 2 plus angle 3. This is 90 degree because this plus this is 90 degree, because this is 90 degree. Similarly, this plus this is also 90 degree. So we are getting twice of angle B equals to 90 plus 90, 180. Angle B equals to 90. Is it clear? One angle we got 90. This angle is 90. This is the perpendicular bisector. This is the perpendicular bisector. In right angle triangle ABC, now just listen to me, what am I saying? These two triangles are similar. The ratio of the length is equal to 1 of root 3. This triangle, because here the perpendicular is dividing them into similar triangle, then this ratio and this ratio, x is to y. These are similar triangle sides of similar triangle. This is B. We are getting xy equals to some 1 is to root 3, like that, isn't it? So now do you have the knowledge of trigonometry? I think all of you are having the knowledge of trigonometry. We got the angles to be 90 degree, 60 degree, 30 degree. 90 degree, 60 degree, 30 degree. Simple knowledge of trigonometry here. And the most important point here in this question was that this BE, whenever we are given with this kind of situation, that a line is breaking it into similar triangle, it is obvious that we have to consider this to be 90 degree. We have to consider this to be 90 degree. This E point. We have to consider this to be 90 degree.
We have proved it considering it to be 90 degree.
And we have proved it considering it to be 90 degree. If you are not just even satisfied that, no sir, it maybe some other possibilities are there, let us consider BE perpendicular to AC. If I am writing this, nobody can cut, because I am considered to be it 90 degree. I am considering it to be 90 degree, and I am showing that all the criteria of similarities are also filled up. I have taken all the possibilities, I have dismissed those possibilities, and I have arrived in my answer in the right way. Because these two triangles are similar, and the ratio is given to be 1 is to root 3. Then using trigonometry, I can show this. The angles are 90 degree, 60 degree, 30 degree. Are you getting it? Let's consider the angle be perpendicular. This is the way of solving this problem. Now, I hope you all are having the concept of ratio of the areas of similar triangle. Ratio of the areas of similar triangle are proportional to the ratio of the squares of the sides of similar triangle. That means if we are having two similar triangles, ratio of areas of similar triangle. If we are having two similar triangle PQR, let its area be x, this area be y, then x over y, we are having p square over a square. Generally, the side opposite of the angle are denoted by the small letters, okay? P, this is Q, this is R. These are the general conventions. I hope you know this. Okay, this is our relation between ratio of area of similar triangles. Let's solve a difficult problem. Not difficult. This is next question. Let Q be the point inside triangle ABC. We have any triangle ABC. In it we are having a point Q. Okay, any arbitrary point Q. Let Q be a point inside triangle ABC. Straight line passing through Q. Okay, straight line passing through Q. Parallel to the sides of the triangle. You just see, parallel to the sides of the triangle. All the three straight lines parallel to the sides of the triangle. Divide the triangle into 6 parts. 1, 2, 3, 4, 5, 6. Here I missed a part, that's why I have given star. 3 of which 6 part. 3 of which triangles of areas. 3 of which are triangle of areas S1, S2, S3. Okay. 3 of which are triangle of areas S1, S2, S3. Prove the area of the triangle. I guess that I have explained the question that Q is any point lines parallel to the sides of the triangle divided into 6 triangles, and we want to find the areas. We want to prove this. Question is very clear to you guys. Okay, now you just think yourself that how you can approach this question, then definitely I would solve this problem. It's really an easy question, just we need the diagram. I'm approaching it now fast. Just we need a beautiful diagram for this problem to be solved. Let me take any point Q. Okay. Now suppose this is S1, S2, S3. Let the triangle be A, B, and C, and it is Q. This point is Q. A, B, C, Q. Then we have D, E, F, G, H, I. Okay. S1, S2, S3. We have to prove it. Now, how do we prove it? Let area of triangle ABC equals to S. Okay. Now it's quite easy. First of all, can you just say me what is the value of root over of S1 over S? You just say me this. Problem is solved only at this point. Just using this you say me. Using this, we can write this as GF over AC. Am I correct? We can write it. Similarly, root of S2 over S can be emphasized as. In terms of AC, if we are emphasizing, then we have now let's try to write this also in terms of some AC. S2, you just see which line is correspond to AC. This QH, yeah, QH, and we have got GF, QH, and S3 over S, root over can be written as AC over, this is S3, QE, QE. Now, if we just add them, what we will get? Now you just think, this line is parallel to this line is parallel to this line, this is a parallelogram. This line is parallel to this line parallel to this line, this is a parallelogram. This is equal to this part, and this line QE, Q equals to FC equals to FC over AC equals to QH is AG. Now if we just add them, we have GF plus AG plus FC, which will give us AC. So if we just add them, S1 over S plus root of S2 over S plus root of S3 over S equals to 1. AC over AC. Is it clear? I think there was a little problem in my question. It's coming to be root S1 plus root S2 plus root S3 whole square. Okay, so there was a problem in the question. This would be root S1, root S2, root S3. I'm sorry. This was my mistake. That's why I'm thinking that why you guys are unable to solve it. Sometimes this may happen. This happens with anyone. This can happen with anyone. I'm also a human. Mistakes are bound to take place by human. Now let's practice some good question. These were easy questions. Now we'll practice some good question. First question I am giving. In triangle ABC, angle A is to angle B is to angle C equals to 1:2:4. Prove that 1/AB plus 1/AC equals to 1/BC. No trigonometry. Purely construction based question. In triangle ABC, angle A is to B is to C equals to 1:2:4. Prove that 1/AB plus 1/AC equals to BC. Should I solve it? Okay, I'm solving it. Now just see. ABC alpha twice alpha 4 times of alpha. Is it clear? Now I am giving a simple hint. Extend this to any point D such that this BD and this AC are equal. BD and AC are equal. This is one hint. Now you just think. And one more hint I can give you is that extend VC to some point E such that is AC equals to AE and join them. Now the problem is solved. Yes, I have solved it. Now use angle chasing. Little bit of angle chasing you can use. Little bit of angle chasing is allowed. I'm just drawing a clean diagram so that it will be easy for us to understand. I denote the extension with which color? Gray, okay. And denoting the extension with gray color so that it would be easy for us to understand. Now my diagram is completed. This is my proper diagram. A, B, C, this extension D, BD and AC equal, this is also equal. This is alpha, 4 alpha, twice alpha, this will be thrice of alpha, isn't it? Exterior angle property, this and these are equal, this is thrice of alpha. I was saying just now, I was simple angles easily. Here we are getting 7 alpha equals to 180 degree. Then we are getting 6 alpha, this is also alpha. Is it clear? Is it clear or not? It's clear, I hope. Then this is twice alpha. This is thrice alpha. This angle is 5 alpha. Is it clear? It's clear or not? Replying back. This is how do I understand that you're understanding. Now you find. Now it's a difficult task. Find angle E, not, yes, try to find this angle. Try to find this angle with the given conditions in your mind. Try to prove it. Try to prove it. Some would say that, sir, this is an isosceles triangle. But why or how this is an isosceles triangle? Here is my question. Why or how this is an isosceles triangle? You just see, this angle is what? Angle EAB, twice alpha. Angle EBA also, twice alpha. Then what we are having? EA equals to BE equals to AC, and AC equals to PD. Therefore, this is also a isosceles triangle. This angle is alpha. There is no confusion. Now you prove the similarity that you are getting from these angles. Try to prove it. Having all these angles and criteria in mind, now you try to prove some similarity. You just see alpha, 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 4 alpha, 2 alpha, alpha, 4 alpha, 2 alpha. Are you getting my point? Then angle, triangle ABC is similar to triangle. Which triangle? Can you just say me? Just say me. Which one? Which triangle? Can you just say me which triangle? D A E. Now we are done with it. Now the main question is that why do we approach, or how do we approach this kind of question? What was the question, first of all? Those who are not understanding that why I am taking this kind of approach. Just you see, what is this? It's nothing else but AB plus AC, AB into AC, 1 over BC, AB plus AC divided by AB can be written as AC over BC. We have to prove this part. And for this, we are approaching towards this. Now just see what we are having. What is the value of AD? What is the value of AD? AB plus BD. BD is equals to AC. AB plus AC. That's why we just constructed like that. Okay, that's why we just constructed like that. AB plus AC. Are you getting the point? How this construction's idea is coming? That idea will come to you also if you practice a large number of difficult questions. Then we are having AC by BC. You just see. AC over BC. Every concept you know, and this is the gist of PRMO. This is the gist of IOQM. This is the gist of Olympiads. This is the gist of RMO. This kind of question can come in RMO. Now can't you prove it from this part? Can't you prove it from this part? I am just proving. AD over AB. What can you write? Can you write it as A over BC from this similarity criteria? That is, AD is what? AB plus AC. AB plus AC. AB equals to what? Equals to what is coming? A is what? AE and AC are equal. AE and AC are equal. I just repeat. AE and AC are equal. By construction, this can be written as. Now we are done with our proof. This can be written as AC over, what was the necessary proof? BC. From this we can prove it. This is that. You are getting this. So hence proved. So you have to take the idea for construction just by changing the question a little bit. What's happening? Just by changing the question a little bit, you have to take the idea. This is my next question. ABC is any triangle. E is any point inside triangle ABC such that the lines AD, BE, or the line segment CF passes through P and meets at DEF respectively. We have to prove that AP by AD plus PP by BE plus CP by CF AP by AD plus BP by BE plus CP by CF equals to 2. Actually, there are two parts of the same question. Two parts of the same question. Another part of the question is PD by AD, PE by BE plus PF by CF equals to 1. There are two parts of the question, and using some easy concepts we can prove them. The proof is rarely not acceptable anywhere in the market. I have just redrawn the diagram. This is any arbitrary point P. Okay, same thing only. Just I have changed the diagram for better understanding of the problem. Now I will use little construction. What are the little construction I will use? I will just extend it. Okay, I will just extend it. I just extend BC to any point. No sir, no any point. Not any point. And I just draw the perpendicular from A to BC. Let it be N. And here I will draw the perpendicular from P. Let it be M. So these two are perpendicular on the same line. They are parallel also. We have AN perpendicular to BC. We have AM perpendicular to BC. We have AN parallel to, not AM. This is PM. AN parallel to PM. From here you try to prove a similarity. Or I am just showing you the similarity. The triangle DPM similar to triangle. What is D? Aren't you getting this point is D from A, D, E, F, okay. Triangle DPM similar to triangle DPM. This triangle DPM and this big triangle DAN are similar. DAN are similar. How? Because angle DPM equals to angle DAN. Corresponding angle, yeah? Corresponding angle. Angle DMP equals to angle DNA. Okay. Is it done? Now just think. What criteria we are having from this? PM by AN equals to PD by AD. Is it correct? PM by AN equals to PD by AD. There shouldn't be any doubt. Then you are having area of triangle PBC is what? Area of triangle PBC half into BC into the height PM. Am I correct? The height PM. And area of triangle ABC is what? Half into ABC. AN into BC. Half BC cancel. So what we're having, area triangle PBC over area triangle ABC equals to PM by AN equals to PD by AD. Now the next part of the question, can you just say, is it now difficult? Is it now a little bit difficult for you guys? PD by AD plus PE by BE plus PF by CF equals to area triangle. Now just see the magic. PBC, yes, this triangle is filled by what? PD by AD. Similarly, PE by BE will give us this triangle. PE by BE will give us triangle APC. And this will give us this triangle. Okay. So if you just see this triangle area plus this triangle area plus this triangle area are added here. So what we are getting? Triangle ABC. And below them, for everyone, we are getting triangle ABC. This is triangle ABC over area triangle ABC equals to 1. Hence the first part of the question is proved. After proving this part,
This was our first part.
Actually, we are supposed to prove the first part of our question is proved, and now we want to prove the second part of the question. Now for the second part of the question, what we will do? We'll just subtract. Let this be equation 1. This be equation 1. If we just subtract, what we will get? We'll get 1 minus PD by AD plus 1 minus PE by BE
P by B.
1 minus PE by BE, and we would get 1 minus PF by CF. 1 minus PF by CF. Now 1 can be written as AD over AD. This can be written as AD minus PD over AD plus this can be written as BE minus PE plus this can be written as CF minus PF, and 3 minus this first equation is what? 2, because the value of the first equation is 1. This is equals to 3 minus first equation 2. This is equals to 2. AD minus PD is what? AD minus PD will get AP over AD plus BP over BE plus CP over CF equals to 2. Hence, we just proved it. And what was the main concept used? Concept of similarity. Now let's go for the last question. We have triangle ABC such that angle A equals to twice of angle B. We have to prove that AC square plus AB multiplied by AC equals to BC square. We need to prove this. Let's try to draw the diagram. we have triangle ABC. Let's try to draw the diagram. What we have, you just see, this is A, this is B, this is C. Am I correct? Are you getting my point? And suppose I am drawing a line like that way. Is it clear? Angle A is twice of angle B. So I am drawing this line. That means what? That this is the angle bisector. That would be my most simplest approach. This is an angle, this angle are equal. This side are also equal. Now let's try to prove it. Now you can easily prove that triangle CAD okay, is similar to triangle CBA. How? Because this C angle is common for this both of these CAD and CBA, isn't it? And CAD and CBA are equal. We just now proved it. Now from this we can iterate what? We can get AC square equals to BC into CD. We can get AC square equals to BC into CD. Now let me do it fast. AC square equals to BC into CD. Since AD bisect angle A, now you just see here we are applying angle bisector theorem. AD bisect angle A. We are having AB by AC. Because this is the angle bisector. Okay, we just did it in angle bisector theorem. AB by AC equals to BD by CD. Now we just proved it. Now you try to find the value of AC square plus AB into AC. Now you try to find the value of AC square plus AB into AC. AC square plus AB into BC. Okay, we just try to find the value of this part. What we can write? Let's take AC square common. AC square common. 1 plus AC square common. AB over AC. Is it clear? AB over AC. Is it clear? Is this common taking method clear? Now AC square can be written as BC into CD from here. And AB by AC can be written as, all of these questions were really interesting, isn't it? BC into CD. We just showed it here, yeah. BC into CD. And AB by AC what? From angle bisector theorem we are getting BD by CD. 1 plus BD by CD. Now if you just multiply them, this is CD. What we will get? Let's multiply the entire expression by CD. We'll get CD plus BD. What's the value of CD plus BD? You just see. CD plus BD. We get BC. BC into BC equals to BC square. Hence proved. We were asked to prove this only. We just prove it. So we have seen how to approach the questions. Of similarity of triangle. Just little construction, illustrating the question. Sometimes problem solving strategies for this kind of triangle is to construct angle chasing. We have seen examples through angle chasings. We have seen example by means of area. We have seen example by directly using the area. We have seen through angle chasing. These are the strategies. We have seen that how we are altering the question, to find a solution. We have seen all these things. We have seen how we are considering some cases. Like here we considered in this question, let it be perpendicular, because if it's perpendicular also, then also it has to go, if it's going for the general cases, isn't it? And if it's not perpendicular, we will not get similar triangle. You will understand this if you just study the question with greater depth. Then we did case studies and we just sort out the extra cases that are not invalid cases. Then we just prove it. So these are the approaches. We have to focus on the approach, not the particular question, because particular questions are not coming. These questions, it's possible that none of the question will come in the exam, but the concept that we are gaining from this part may come in the exam. So we're just over with our discussion.